Hello children, welcome to Max class. How are you all? Hope everyone is fine at home. And today let us begin the session with a thought. A day without prayer is a day without blessing, and a life without prayer is a life without power. Yes, it's a good habit to begin and end the day with prayer, because the most powerful weapon against trials. It is the most effective medicine against sickness. It is the most wonderful gift that we can give to someone. Before we give material gift to our friends, let us make it a habit to remember them in our prayers, because it is the most valuable gift that we can give to our loved ones. And prayer does not change God, but it changes him who prays. As humans, we have the habit of asking God, today we should not have any test. God, today I should not be caught by the teacher for not doing my homework. Please God, today I should win in the match during PT period. Isn't it, children? We all have such prayers to God. But do you think God changes because of our prayer? No, children. It changes us, and it gives us energy to face whatever comes in our way. Prayer gives us energy to face the challenges, to make us happy, to have a positive attitude in whatever we do. So let us keep up this habit in all coming days. Okay children, let's begin now. And let's have a small recap what we have learnt in previous class. It's about the rational number. It is defined as a number that can be expressed in the form P by Q. So, is every fraction a rational number? Yes, it's a rational number. Is every integer a rational number? Yes, because any integer minus 100 or minus 5 or plus 80, any integer can be written in the form of P by Q, where Q is equal to 1. And all decimals are also rational numbers. What other things we discussed in previous class? It's about equivalent rational numbers. It is just similar to equivalent fractions that you were very familiar right from class 4. Rational numbers in a number line. We discussed all these things in previous class. Let's have some example. How to represent minus 1 by 2 in a number line. It should be a straight line, children. A line in the sense it has no endpoints. Hope you remember those things. 0 to 1, then 2, minus 1, minus 2. Here we will have positive 1, then it keeps on going. Now I have to locate minus 1 by 2. It means this 0 to 1 has to be divided into 2 equal parts. So we will have only one break. So 2 equal parts. This is one part and this is another part. So this will be represented as minus 1 by 2. Okay. Now, when I ask you to represent minus 1 by 5, 0, minus 1, minus 2, here we will have plus 1, minus 1 by 5. Whenever we have proper fraction, it means that it lies between 0 and minus 1 or 0 and plus 1, depending upon the sign. If it is an improper fraction, it will be greater than 1. That's why now I am dealing with between 0 and 1 alone. I am not thinking about something beyond minus 1. Because it's a proper fraction where the numerator is smaller than the denominator. Okay. How many parts should I have now? How many equal parts should I have now to locate minus 1 by 5? Yes, I should have 5 equal parts. 1, 2, 3, 4, 5. I have 4 small lines between 0 and 1. I'm sorry children, it should come properly. This is 1 and this is 0. Okay, in between these two, we have 4 smaller lines which divides 0 to minus 1 into 5 equal parts. So this is minus 1 by 1, minus 1 by 2, 1 by 3, 5 by 1, 5 by 5. 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, and this is equal to minus 5 by 5, which is equal to minus 1. So where is minus 1 by 5 now? It is here. If I ask you to locate both these numbers on the same number line, how will you do? Will you locate minus 1 by 5 after minus 1 by 2 or before minus 1 by 2? Of course, it is going to be smaller than minus 1 by 2. It will come between 0 and minus 1 by 2. You are right. How to draw a number line representing two rational numbers in the same number line? Any idea? Yes. I am going to find the equivalent rational numbers for minus 1 by 2 and minus 1 by 5. 0, here we will have minus 1 and here it keeps on going minus 2. Here plus 1. Okay. How to find the equivalent rational numbers for minus 1 by 2 and minus 1 by 5? So that both of them have the same denominator. Yes. It's like cross multiplication, no? We will take LCM. 5 2s are 10. So we have to multiply by 5. It will be minus 5 by 10. Here we will have multiply by 2. That's what I showed you in cross. This 2 has to be multiplied over this fraction and this 5 has to be multiplied over this fraction. So we will get minus 2 by 10. This 5 by 10 is equivalent to what? Minus 1 by 2. This is equivalent to minus 1 by 5. Okay? Hope you understood how I got minus 5 by 10 and minus 2 by 10. So I have to divide this part between 0 and 1 into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be 0. This bigger line will be 0 and this bigger line will be minus 1. See now check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 parts. I didn't count the number of small lines. Instead I counted the number of parts. Hope you were able to understand how I have divided. So this is nothing but minus 1 by 10. This is minus 2 by 10. And this will be minus 3 by 10. Is it clear children? Okay. Likewise, you will mention minus 2 by 10 here and minus 5 by 10 you will have here. See, it is equal to half of between 0 and 1. Hope it is clear children. Now we also learnt about the standard form. It's just about, we can bring it to standard form either by multiplying or dividing by the same number, both in the numerator as well as denominator. It's very simple. You have to cancel it. Try to practice cancellation as much as possible. 6 3s are 18, 15 3s are 45, 2 3s are 6, 5 3s are 15. So which is equal to minus 2 by 5. 18 by 45 and minus 2 by 5 are equivalent rational numbers, minus 18. Okay. Similarly, we can simplify minus 12 by 18 in 2 table or 3 table. 4 3s are 12, 6 3s are 18, 2 2s are 4, 3 2s are 6. Here we get minus 2 by 3. Okay children. And here, which of the following, now we are getting into today's concept, which of the following pairs represent the same rational number? To do so, we are going to have a general pattern. As we did in the previous case, here also we are going to consider these denominators and multiply it with another rational number. both the numerator and denominator. So we will have minus 7 by 21 into 9, here also 9, and we have 3 by 9, it has to be multiplied by 21. So what will I get? 63, 189, and 363 divided by 189. Are they both same rational number? No, because they are different in signs. Though the numerical value is different, they are opposite in sign. So they are not same rational number. So you have to write in statement, no, they don't represent the same rational number. Okay, you need not take much time in doing all these things. When you have two numbers of opposite signs, immediately you can say, no, they don't represent the same rational number. But I did this calculation to give you a uniform way of finding it. Okay, here coming over to the second thing, here it's the same concept, children, finding the LCM of these two and finding the equivalent rational numbers. Okay, what will be the LCM for 20 and 25? You will take much time to do all those LCMs. So we have shortcut of finding the denominators and multiplying them both in numerator and denominator. This has to be multiplied with the opposite denominator. This is 25. Okay, it's the same concept of LCM that you were practicing right from class 4. Okay, and here we have 20 by minus 25 into 20 into 20. So anyhow, these two denominators are going to be same. So I'm not going to multiply and find what is going to be the denominator. I will just multiply the numerator and check whether they are same. Here we have minus sign, don't forget that. So if I multiply 25 into 16, we will have 400. Here we have minus 400 divided by 20 into 25. I'm not worried about what is going to be here. And what about here? Again it is 20 into 20, 400. What sign will I have here? Minus, because the standard form of writing a rational number is that numerator should be negative and denominator we should not have negative. In denominator we should not have negative. 25 into 20. So both represent the same rational number. Likewise, we can do one more sum. Here coming over to the seventh sum. Just by looking at it, you can say these two will get cancelled now. The standard form of writing a rational number where both are negative, numerator and denominator, it becomes positive. This is a positive 5 by 9 and this is negative 5 by 9. So they are not same rational numbers. Okay, coming over to this, I have to multiply by 9 here. Here we are going to multiply by 3. So compare this 9 and 3, are they? No, they are not same rational numbers. Just by looking at the question, you can immediately find the answer. Only when we have bigger numbers, we have to multiply and see. See, now multiply by 8 into 15 and 5 into minus 24. Okay, and check whether they are same rational number or not. I have completed 1, 2, 3, 4 and the remaining 3 alone is homework for you. 3, 5 and 4. Okay, children? Now the next question is how to compare rational numbers. Again, let us talk about the integer line and it is 0. We have minus 1, minus 2, minus 3, etc. minus 100. It keeps on going. When I come to here 1, 2, 3, it keeps on going. And as we move towards right, we have bigger number. As we move towards left, it is smaller number. Okay, if I compare minus 3 and minus 2, which is bigger? If I compare minus 3 and minus 2, which is bigger? Minus 2 is bigger. In negative direction, the number with bigger magnitude and negative sign will be the smaller number. Hope you could recall that. The same concept will be continued in rational numbers also. Like minus 3 by 5 is less than minus 2 by 5. While comparing the rational numbers, we should see that the denominators are same. Only then we can compare. Is it clear, children? Shall we try out few examples? Okay, come on, let's continue in next video.